In this video, I'm going to show you how to use the SRI512 and SRIX512 NFC tags. These two tags are manufactured by a company called ST Microelectronics. So if you're a software developer or a student of electronics and computers and you're electronic hobbyist, who know how to program, so you will benefit more out of these videos because I'm going to speak at the command level. If you're a non-programmer or a casual user, you will still get to know what these type of tags are, how the data is stored, and probably with this knowledge, if you come across any software so that allows you to read and write, so you can benefit from this video as well. Now this is what I'm going to cover in this video. Probably I'm going to make 2 or 3 videos to cover all this concept. So as I did with the other tags, we're going to see a general introduction about these two types of tags, and I'm going to show you where to buy these tags. And in fact, these tags are not very commonly available on the internet, so I'm going to tell you now where you can buy this. We're going to understand the datasheet of SRIX512. Now this is where it's going to benefit the software developers or the students of computer science and electronics. So if you understand the datasheet well, so you can start programming these tags. We're going to see the memory structure and various commands that are supported by these tags. And so in order to use any tag, we need a reader writer that supports this type of tags. I'm going to use a reader writer based on the CR95HF chip, and this board is also called as a discovery board or the development board. This is also from the same company, STM, the ST Microelectronics. I'm also going to show you how to use these tags using some of the RFID learning tool I have created. So I'm going to show you how to use these tags using the ACR122U reader writer and a software that works with the CR95HF development board. You're going to see if you have got a Omniki 5421 reader writer, you're going to learn how to use this tag as well. And finally, I'm going to show you how to use this tag with a bare minimum hardware, that is having a PN532 board with a UART or in UART mode or a USB to TTL cable. So this is the 100 feet look at these type of tags. So these tags are of type ISO 1443 type A. So you have to be very careful here. This is not type A. This is a type B. Sorry, this is a type B tags, not a type A tag. Now because this is a type B tag, you must look for a reader that supports the ISO 1443B protocol. And say for example, I have made so many videos and I also used a RFID reader writer that's based on MFR522. Now this is a reader writer board that does not support the ISO 1443B type of tags. This supports only of type A. So you cannot use these boards to read type B tags. Now this is the overall structure of the SRIX512 tags. It has got 4 sections. The first one is the OTP. This is called one-time programmable blocks. This is something if you already know about the MeFair ultralight tags, there's something called OTP, which is used mainly for the ticketing applications, and this is similar to that. It has got a counters and it has got the user memory. So as the name says, counter, the purpose of the counter is to count down, and there are in fact 2 counters in this chip. you got user memory. This is where you can put whatever data we want, like the customer name, address, and so on. And it has got a system memory where you can define the locks, and some of the sections are part of the system memory blocks are reserved as well. So overall it has got a very simple structure: the OTP, the counter, the user memory, and the system memory. So the most important thing we need now is the datasheet. If you go to Google and type SRI512 datasheet, and you will get all these listings. If you start just clicking, look for the one that shows PDF, and if you're going to see, let's see what this is. Now this is a 47-page document. It says ST25TB512AC. Now looks like this is a different chipset or reader altogether, but so this is very identical to the SRI512. You can use this document to understand the SRI512 tag. The next one, you got STM SRI512, and this is the proper SRI512 document, and you can, this is also a 47-page document, and you can download this and you can use this as well. So likewise, if you go to this link here, so it looks like you can also buy the SRIX512 tags from here, and you can get easy access to the other documents as well. You got SRIX512 and SRI512, and you also got the other tags which have already made the videos on SRIX 4K. I'm going to try this time SRIX512, and if you click the very first link, so this is what I was bit shocked to see this document, because it says SRIX512 is an obsolete product. So looking at this, probably you may be thinking whether to continue this video to understand this. So I would advise you, there's good and bad here. The good thing is, if you consider this as an obsolete tag, probably you can buy these tags for a cheaper price, and also by reading this SRIX512, you will also understand the various other tags from ST Microelectronics which are very similar in structure. So because I'm new to this tag as well, I just don't understand why these tags are obsolete. So I will not be using this SRIX512 document, and there is one difference between SRIX and SRI512. So it's the X here. Now the only difference here is, if you scroll down, there is a section called, it's anti-clone functions. Now anti-clone, as this paragraph says, so using this feature you can find out whether a tag is the real tag manufactured by STM and not an emulator or any other clone tags. Now I myself am not able to test this functionality, because you need a specific type of reader writer chip. But if you have got some experience with working with NXP, like I got more experience using the NXP tags. So say for example, the NXP, there is a tag called the ultralight EV1. Now every ultralight EV1 has got a signature which is stored inside the tag itself. So in fact, it it is not on the tag. Every tag has got the RFID tag, just a tiny microchip here. Now this signature is printed while this tag is manufactured. Now there is a service where I can read this signature, send it to the service, and this is a 32-byte signature, and this service is running in a NXP server, or it can be running on your local server as well. So there is a functionality, there is some logic or program running in this server that can verify that these 32 bytes are authentic, and with that you will come to know that the tag what you have in hand is the original tag from NXP and not an emulator, or is not a clone tag. So I still haven't seen any clone tags of EV1, and since this SRI512 is also very new to me, I'm still not very sure whether you can buy any cloned tags. So if you're doing a project that requires a very high level of security, probably you might have to go with the SRIX512 or any SRIX tags which supports the anti-clone functionality. Now I have downloaded this datasheet from the st.com website, and I'm going to highlight some of the important points that's useful for a developer. So I'm going to ignore those things that are more on the electronic side. So I would be interested to know that these are of type B tags. So it's mentioned here, and this is a 13.56. This is a high frequency tags. So, and this is also something you need to remember. This is the speed of this data transfer is 106 kilobits per second, and this supports 8-bit chip ID, and it has got 2 counters, and it has got each tag has got 64-bit unique identifier, which is something different from if you compare this with the NXP, the type A tags, where in the type A we speak about the single size, double side, and triple size UIDs. This has got 512 bits. You have to be careful here. This is not bytes, it's a bits. So 512 bit EEPROM. It also has got write protection feature where you can lock the memory blocks, and you can read a block, write a block. And interesting, which I like about these SRX tags is these numbers. You can do 1 million arrays and write cycles, and look at this, 40 years of data retention, and all other things. These are all taken care of by the reader writer. Next, as a developer, you like to know the structure of the data frames that are exchanged between the reader writer and the SRIX512. So every frame consists of the start of the frame byte, the command byte, the data byte, and the 2 bytes of CRC, and followed by the end of frame byte. Similarly, any data you get from the tag starts with the start of the frame, the data, followed by 2 bytes of CRC, and finally the end of the frame. And in fact, we don't have to know about the number of bits. It's a 12 bits here. All these bit and the timings, they are all taken care of by the reader writer. The next is page 13. It speaks about the CRC. Most of the time you don't have to worry about CRC, because most reader writer, they calculate the CRC, they verify the CRC, and they also attach the CRC while sending the data. Now this is most important for us. I mentioned before, SRI512 has got 4 sections. The first section is the resettable OTP bits. Now here the memory is organized into blocks of 32 bits. Now this particular tag has got 16 blocks. starting from 0 to 15, number from 0 to 15. So the first 5 blocks are called OTP, and the block number 5 and 6 are 32-bit binary counters, and the remaining blocks are for the user data. Again, the data is lockable. So once it is locked, these blocks become a read-only or like a ROM. If you scroll a little bit down, now this is a special block with the block address 255, and this block has got the locking bits. Now there's a bit information here you can use to lock, and followed by you got some reserved words, and this is the fixed the chip ID. Now after that, every tag has got 64 bits of UID, and these blocks are not accessible. We can't. There is no command to read these UID 0, UID 1. These are automatically returned by the tag depending on certain commands. So you just have to learn how to read and write and understand how the various blocks works. I have got one more video which I have done a few years ago. That's about SRIX4K. So in that video I've explained most of these document features in detail. So I would advise you to take a look at that video so that I can make this video pretty short. And just to highlight a couple of pages here. Now the OTP area is explained here. Now these tags are something different from the NXP. When you buy a new tag, all the memory bits are initialized with the bit 1. So 1, you can treat this as a erased state, and 0 means it's a written state. Like if you have seen some of the NXP tags, the brand new tag will have most of its memory set to zeros, and we are going to write the ones, whereas in this SRI series tags, the brand new tag will have the bit 1s, we are writing the 0. Now the resetable OTP area, so this is like a one-time programmable. That's what OTP stands for. Now here's an example that says, so when the bit is already 0, you cannot set it back to 1. However, there is you can do that with the use of what is called as a reload command, which I'm going to explain in detail later. So most of the other things I'm sure you can understand by reading this on your own. The next important thing is the OTP lock register, which is in the system area. As you can see here, there are 16 bits and each bit locks a specific block. Now we know that this particular NFC tag has got 16 blocks, and all these blocks can be locked. Now if you have seen these SRIX4K tags, so if you want to compare 4K with this, in 4K you cannot lock the OTP and the counter. You can lock a few pages of the user memory. Because SRX4K is a very huge memory. It's a 4 kilobits of memory, but only that if I remember it right, the top probably 15 user pages you can lock it, but not the OTP and the counter. So there's one important thing mentioned here. So when a block is locked, you cannot erase this at all. There's no way you can erase. So that you have to keep in mind. So next you have to understand how this NFC tag works. You have to understand this state transition diagram, which I'm going to explain when I show how to use these tags using one of the reader writers. So there are altogether 6 states: the power off state, the ready state, inventory state, selected state, deactivated, and deselected. And again, these states are pretty obvious if you look at this diagram, and also this explanation here as well. So you have to understand how the anti-collision works. I've explained this anti-collision in very much detail in my SRIX 4K videos. I would advise you to look at that. So I might show you how the anti-collision works in SRIX512 tag as well. And this is the best explanation you'll come across in this document, and how this anti-collision works. So these are the various commands. In fact, there are not many commands. You got initiate command, the pcode16 command, slot marker command. So the first three commands are related to the anti-collision, and the reading the block, writing the block, getting the UID, and these are all to do with the transition within the state. You can go to inventory, you can go to a selected state, and you can go to a completion state. So these are various commands. Now if you see the data sheet of SRIX, you'll also come across I think probably it's 0A, I think. So you'll also come across a command called authenticate, which is not present in this tag. And from this point on, every command is explained in very simple words. Anybody can understand that. And probably now you have to keep this data sheet as your reference guide. Now once you start using the command, so you have to come back to this and understand the various command bytes and various parameters. And some of the commands, they do not return any data. So it's very common, as a developer, we always think that when we send a command to the tag will respond. Now in SRIX512 or in SRIX4K also, for some commands you don't get a response. Say for example, when I use a write command to write 32 bits of data, after the write you'll never get a response. The only way for you to make sure the write was successful or not successful is to read the data back and compare yourself whether the read and write data are the same. And probably that's all in this video. So in the next video I'm going to show you how to use these tags using a few redirectors. Thank you.